Crystalline solids have a sharp melting point at which they immediately change into liquid. They are therefore considered as true solids. Amorphous solids, on the other hand, do not have sharp melting points. They can be softened, moulded, and blown into various shapes over a certain range of temperature. Amorphous solids behave as crystalline at certain temperatures and are therefore considered as pseudosolids or supercooled liquids. Crystalline solids are anisotropic in nature. Due to the systematic or ordered molecular arrangement in these solids, some of their physical properties, such as refractive index and electrical resistance, change with any change in their direction. For example, coefficient of thermal expansion of the silver iodide crystal is positive in one direction and negative in the other. The phenomenon of anisotropy in crystals provides strong evidence of the presence of ordered molecular arrangement. Crystalline solids are rigid, and their shape is not distorted by mild forces. Amorphous solids are isotropic in nature. That is, they exhibit the similar physical properties in all directions. This is due to random arrangement of molecules in the solid. Crystals are bound by plane faces. The angle between any two faces is called the interfacial angle. For a given crystalline solid, the angle is definite and always remains constant. When a crystalline solid is hammered, it breaks down into smaller crystals of similar geometrical shape. Crystalline solids have definite heat of fusion values, while amorphous solids do not. Another important property of these solids is symmetry. Crystalline solids display plane of symmetry, axis of symmetry, and center of symmetry. On the other hand, amorphous solids do not display any symmetry. Let's summarize. Crystalline solids are rigid and incompressible. They have definite geometry, melting point, heat of fusion, and symmetry. They are anisotropic and possess interfacial angles. Amorphous solids cannot be compressed. They have no definite melting point, no heat of fusion, and no symmetry. They are isotropic and do not possess any interfacial angles. There is no sudden change in volume on melting, and they break into two pieces with irregular surfaces.